Alright guys, day 10. How about lesson number 5? Lesson number 5, we're going to skip the opening exercise because it wants you to use string and construct perpendicular bisectors. One of the things it wants you to talk about is what were some of the differences. We'll think about using string versus your compass. Some of you may say, well, the string's going to be easier because the compass is giving you a lot of frustration. But in all honesty, you have more of an accurate chance of having a better perpendicular bisector using your compass than you do with string. Because string, if you stretch it too tight, if you don't stretch it tight enough, there's just a lot of factors there. Alright, so let's go to our exploratory challenge. Alright, so when 3 or more lines intersect in a single point, they are blank. It is what we call concurrent. Alright? They are concurrent. So if I were to actually construct perpendicular bisectors in the opening exercise, and I'm just going to, I'm not going through the steps to do it, but if I were to do perpendicular bisectors, the point would be you would actually see what would happen would be they would all three come together at a point, okay? So when 3 or more lines intersect in a single point, they are what we call concurrent. And the point of intersection is the point of concurrency. So all 3 of these lines are concurrent. This would be the point of concurrency. Okay? You saw an example of a point of concurrency in yesterday's problem set, which you did some of it, but not all of it. And the opening exercise above, so I showed you that, when all 3 perpendicular bisectors pass to a common point. The point of concurrency of the 3 perpendicular bisectors is what we call the circumcenter of the triangle. Guys, right now we are learning vocabulary. Alright? So if I'm looking at perpendicular bisectors and I have 3 or more, the point that they come together is the point of concurrency, and this is what we call the circumcenter of the triangle. So if I were to label this the circumcenter of triangle ABC, would be point P. Alright, so that would be point P. Alright? And I've drawn one here for you. Here, the point of concurrency is in the middle, or in the inside of the triangle. That's fine. Point P would be your circumcenter of that triangle. Okay? The questions that arise here are, why are the 3 perpendicular bisectors concurrent? And will these bisectors be concurrent in all triangles? Recall that all points on a perpendicular bisector are equidistant from the endpoint of the segment, which means, alright, so looking at this figure, P is equidistant from A and B since it lies on the blank of AB. Alright? So, let's look at this. So P is the same distance from A as it is from C. I'm sorry, we're looking at this side. P is the same distance from A as it is from B because it lies on the, what is this segment, or what is this line here? It is the perpendicular bisector. Alright? So because point P, even though it's the point of concurrency, because point P lies on that perpendicular bisector, then I know it's the same distance from A as it is from B. P is also blank from B and C, since it lies on the perpendicular bisector of B and of BC. So now we're switching to this one. P is on the perpendicular bisector of BC. So what do we know about the distance from P to C and P to B? We know that it is equal. So P is equidistant from B and C, since it lies on the perpendicular bisector. So since we know that, then P must also be the same distance from A and from C. Alright, so now they're telling me that the distance from A to P and C to P is going to be the same. So, we know that AP is equal to BP is equal to CP, which suggests that P is the point of what? Well, what did we just say? The point of concurrency. Of all three perpendicular bisectors. You have also worked with angle bisectors. The construction of the three angle bisectors of the triangle also results in a point of concurrency, which we call the blank. Alright, so this might be a new term for you, but this is what we call the end center. Alright, so the angle bisectors, the construction of the three angle bisectors of a triangle also result in a point of concurrency, which is called the end center. Alright, so it says use the triangle below to construct the angle bisector of each angle in the triangle to locate the angle's end center. Alright, so we would actually use our compass and do all of that, but what I'm going to do is I'm going to just kind of show you for time's purposes. Alright. So remember, a bisector divides the angle in half. Which, what I would suggest you do is use your compass to figure that out. But here we see that you're going to have a point that it comes together, and this is what we call our end center. Alright, that's our end center. Here, perpendicular bisectors, this is our point of concurrency, or our circumcenter. Here we're dealing with angle bisectors, so therefore it is what we call our end center. Okay? State precisely the steps in your construction above. Well, guys, we would construct the angle bisector of angle A, angle B, and angle C, and then we would label the point of intersection as Q. Okay? It's not anything of major importance here. Earlier in this lesson, we explained why the perpendicular bisector of the sides of a triangle are always concurrent. Using similar reasoning, explain clearly why the angle bisectors are always concurrent in the end center. So at any point on the angle bisector is equidistant from the rays forming the angle. So therefore, since point Q is on the angle bisector of angle ABC, then it's equidistant from BA and BC. Okay? Guys, the iPad's about to die, so I'm not going to spend a whole lot of time talking about that. I want to look at the rest of this. I know that we need to know the Y's and everything, but this is kind of just a lot of technical terms. My concern is that you get the vocabulary. All right, so observe the construction below. Point A is the circumcenter of the triangle JKL. Notice that it can fall outside of the triangle. Point B is the end center of triangle RST. The circumcenter of the triangle is the center of the circle that circumscribes the triangle. The end center of the triangle is the center of the circle that is inscribed in that triangle. All right? It wants you on a separate sheet of paper to draw two triangles of your own and see if you can get the circumcenter and the end center. You can practice on that if you'd like. I'm not going to require that exactly because we won't use it a whole lot. How can you use what you've learned in exercise 3 to find the center of a circle if the center is not shown? You can inscribe a triangle into the circle and construct the perpendicular bisector of at least two sides. Then where those bisectors intersect, that's the center of your circle. All right, so this lesson was kind of a quick lesson. There wasn't a whole lot to do. It was more introducing that vocabulary. Guys, practice using that compass.